All right, Algebra 2. We're going to go ahead and look at a system of equations and solving them. So a system consists of at least two equations. You could have three equations or more. And we're trying to find out if we were to graph all the equations on a graph, where would they intersect? Okay, so they all have to intersect at a certain point. And so what we're going to look at is a linear equation. So these are all lines. And so they're either going to intersect in one specific point, so we would have an ordered pair for a solution. They could never intersect, so then they have no points in common, so there's no solution. Or they could actually be the exact same line, and they lie directly on top of each other. And so in that case, we'd have infinitely many solutions. All right, so we're going to go ahead and graph each of these lines. And so they're already set up in the form of y equals mx plus b. So if you remember from probably Algebra 1 and geometry graphing a line, in y equals mx plus b form, the m is the number in front of the x, that's our slope. And we want to kind of think of rise over run. All right, when we graph the slope number. And then the b is the y-intercept. And that's where the graph crosses the y-axis. So y-intercept. Okay, so on number one, we want to graph y equals negative 2x plus 3. So the slope is negative 2, or we could also write it as a fraction, because we want to, again, think of it as rise over run. And then our y-intercept is positive 3. So if we graph this line, we would always graph the y-intercept first. So on the y-axis, so that's the vertical one, we're going to put a dot at positive 3. So we'll count up 3 units and put a dot. Then we're going to use our slope, rise over run, to find another point. Now, since our negative is on the top number, we're going to go down 2, and then 1 is positive, we're going to go in the positive direction, which would be to the right, 1 unit. So we'll go down 2, and then right 1. Okay, that would put our dot right there. Now we can continue this same pattern, go down 2, right 1, go down 2, right 1. You can kind of see that all of these dots fall on a line. We could take a ruler or something straight edge, and then just connect them and get a line. Okay. All right, so now let's do the next one. Y equals negative 1/2 x minus 2. So this has a slope of positive 1/2, and then it has a y-intercept of negative 2. All right, so again, we'll put a dot at negative 2 on the y-axis, count down 2 units. And then our slope is 1 over 2, so this is positive 1, so we'll go up 1, and then right 2. Go up 1, right 2. Again, you can kind of see the 3 dots that fall on a line, and then we connect them. We can find an intersection point, and so it looks like they intersect right here. So this point of intersection solves the system of equations. And so this ordered pair would be 2, so right 2, down 1. So that's the ordered pair 2, comma, negative 1. And that would be the solution. All right, number 2. Again, we want to use the slope and the y-intercept. So here the slope is negative 3/4, has a y-intercept of positive 2. So we're going to graph the y-intercept first, so positive 2. Then we'll use the slope, rise over run, so we'll count down 3, 1, 2, 3, and then right 4, 1, 2, 3, 4. Again, we can go down 3, 1, 2, 3, over 4, 1, 2, 3, 4. It's going to put us over here. And then we can connect them. All right, and then we'll do the other line. So this one has a slope of negative 3/4 and a y-intercept negative 1. We'll put a dot at negative 1 on the y-axis. and then we'll go down 3, and then write 4 again. 1, 2, 3, 1, 2. Okay. And then you only need really 2 points to connect the line. Remember that from geometry. All right. So these 2 lines appear to be parallel, which means they don't cross. And if they don't cross, they don't intersect. So this actually has no solution. And that's because they're parallel lines. All right, now another way that we can solve a system is by using substitution instead of having to graph every time. So with substitution, the idea is to get one of the variables, either x or y, by itself. So on number 3, the first equation, y equals 2x minus 3, it's already solved for y. And so what we're going to do is take this entire expression, 2x minus 3, and we're going to substitute it in for y in the second equation. All right, so make sure you use parentheses. So we'll write 3x minus, and then whatever we're substituting in for y. In this case, it's 2x minus 3. And then equals 3. Okay, so again, we're just getting rid of the y and putting 2x minus 3 there instead. So now we're going to solve this for x. So we'll distribute the negative to get rid of the parentheses. We'll combine like terms. 3x minus 2x is x. Plus 3 equals 3. We'll subtract 3 over. And so we're going to get x equals 0. So x equals 0 it's an okay answer because it's a number. So we know that x equals 0. So now we want to find out, well, what would the y coordinate be? So remember, we're trying to find the point of intersection. And so it's an ordered pair. So now what we do is we take that x equals 0, and we're going to substitute it back into this equation right here. Now, you can plug it into either of the 2 equations, you'll get the same answer. But if you plug it into the one that's already solved for the variable, then it's just going to make it a little bit easier. Okay? So we get y equals 2 times 0 minus 3. Y equals 0 minus 3, so y equals negative 3. So our answer, or the point of intersection, is 0, comma, negative 3. All right, so let's do 4. So number 4, again, we're using substitution. So this one is already solved for x. And we're going to substitute that in for x in the first equation. So again, we want to use parentheses. And then we just write everything else that's in the equation. So here we're going to distribute the 3 in. So it's 6y minus 12 minus 6y equals negative 12. All right, combining like terms, 6y minus 6y, that cancels out, that's 0, 0y. I get negative 12 equals negative 12. Well, since there's no variable to actually solve, we want to look at the numbers, and since negative 12 does equal negative 12, that's a true statement. So this one we get infinitely many solutions. Now, if we were to solve this problem, and let's say the variables canceled out and the left number and the right number were different numbers, then this is how you would get no solution as the answer. All right, and then the last method that I want you to know how to do is elimination method. So elimination method, we're trying to eliminate either your x variables or your y variables. And so to do that, you need to have the same coefficient in front of either the x's or the y's, whichever variable you want to eliminate, but they have to be opposite signs. So same numbers, but opposite signs. So if we look at number 5, we have a 2x and a 4x. So to eliminate those x's, I need both of those coefficients to be the same number, but opposite signs. So what I could do is make that 2x a negative 4x, and to do that, I would just multiply it by negative 2. All right, and then when I combine it with the 4x, they would cancel out. Now, if I wanted to eliminate the y's, all right, I look at the 5 and the negative 3, I need to have those two numbers to be the same, but opposite signs. Well, they're already opposite signs. One's plus, one's minus. But the 5 and the 3 would need to be the same numbers. So the way you figure out what number that you'd want them to be is find the smallest number that 3 and 5 would go into, and that's what you would want them to be. So the smallest number that 5 and 3 would go into is 15. So you'd want to make the top number a 15 and the bottom number a negative 15. To do that, you can multiply the 5 by positive 3 and the bottom number by positive 5, and that would turn them into positive 15 and negative 15, and they would eliminate. All right, so since you get to choose which one you want to eliminate, I would try to find one that's a little bit easier than the other. So in this problem, the x's would be easier to eliminate because I only have to multiply one equation by a number, and that would be negative 2. So what I'm going to do is distribute negative 2 across everything. So that becomes negative 4x plus 6y equals negative 10. And I'm just going to carry this top equation directly above. So I don't change anything on it. So now what I'm going to do is add down. So by adding down, 4x minus 4x eliminate. They cancel out. Adding 5y and 6y, I get 11y. And adding negative 1 and negative 10 together, I get negative 11. So now when I solve for y, I can divide by 11, and I get y equals negative 1. So now I want to find the x coordinate. So to find x, I'm going to take y equals negative 1, and you can, this one, you're going to plug it into either equation. So you can either plug it into the bottom one, or you can plug it into the top one. You'll get the exact same answer, so it's up to you. So I'll just plug it into the top one. So it's 4x plus 5 times y, in this case it's negative 1, equals negative 1. So 4x minus 5 equals negative 1. Add 5. 4x equals 4. Divide by 4. X equals 1. So my ordered pair is x is 1 and y is negative 1. All right, and then 6. Okay, again, we want to eliminate. And so either the x's or the y's. So it's up to you. Let's see. If I want to eliminate the, let's say I want to eliminate the x's. Okay, I have a 3x and a 9x. If I can make that 3 a negative 9, it would add to the positive 9 underneath and cancel out. So that's what I'm going to do. I'm going to eliminate the x's by multiplying through by negative 3. So that becomes negative 9x plus 3y equals negative 12. The bottom one is just going to stay the same. And then I'm going to add down. So negative 9x plus 9x is 0. 3y minus 3y, well, that's also 0, equals negative 12 plus 5 is negative 7. All right, so there's no variables to solve, but 0 doesn't equal negative 7. So in this case, the answer is no solution. Okay. All right, and that is it. All right, so 7 and 8, it says to solve using any method, either substitution or elimination. So it's up to you which method you want to try to use. One thing to keep in mind, to use substitution, you want either a 1 or a negative 1 in front of the x variable or the y variable. If you don't have that, a 1 or negative 1, then don't use substitution and just use elimination. So on number 7, if you look at all the coefficients of the x's and the y's, none of them are 1 or negative 1, so you don't want to use substitution. It just makes it really hard because you'll have to use fractions. So in that case, I would use elimination. So to use elimination, let's see. So I would probably eliminate the x's. Looks like a little bit easier. And so all I have to do is multiply the bottom equation by 2. So I'll carry the top one exactly the same. Bottom one, distributing the 2 all the way through. Adding down, the x's go away. 3y minus 10y is negative 7y, equals negative 8 plus 8 is 0. if I divide by -7, I get y equals, well, 0 divided by -7 is actually 0. Right? So y is 0. That's a number. So now we want to find x, and we'll substitute y equals 0 back into one of these equations, and it doesn't matter which one. I'll just take the top one again. All right, solving for x, 3 times 0 is 0. And then dividing by -4, x equals 2. All right, so now we'll take 2 and our y equals 0, and I'll write our answer as an ordered pair. So it's x comma y, so 2 commas. And then the last one, number 8. This one, again, you could use elimination or substitution. Let's use substitution just because I can see one of the y's has a 1 in front. And so I want to get y by itself. And so to do that, I would have to subtract 5x over. Okay, so if I subtract 5x over, I get -5x minus 4. Now I can take -5x minus 4 and substitute in for y in the bottom equation. Again, you could have used elimination, because it said use any method. All right, so distributing the -3 in. All right, combining our terms, so it's 17x. Subtract 12. Divide by 17. X equals -1. All right, so then we'll take x equals -1. You can substitute it back into any equation, really, but I'll just take it and plug it in right there since it's already solved for y. It's going to make it a little bit easier. All right, so y equals says do -5 times x. So -5 times -1, and then minus 4. So y equals 1. So then our ordered pairs, let's see, x is -1, y is +1. Okay, so that's the answer. One thing to keep in mind when you're doing elimination method, you want to make sure your x's are lined up under the x's, the y's are lined up under the y's, the equal signs are lined up, and then the constant terms are lined up. Okay, so again, you want x's with x's, y's with y's, equal signs, so they all have to be lined up before you start doing elimination. All right, now that's it.